I'm going to talk about England and Wales, and about a project that I've been doing with the England Environment Agency and Natural Resources Wales mainly, but also part of the UK Wetland Technical Advisory Group. And what we've been doing is a project that's been going on for a few years now, and we've been sort of developing ideas and then recently testing them out in the field. So blanket mire landscapes, we've seen lots of those. They're often rather bleak looking. You've got the androgynous bogs that are the habitats that we're concerned with, that have developed under rainfall. Peat builds up really slowly in those wet conditions a long time ago. And this bleak appearance is often deceptive. We've been talking about mosaic habitats and things like that. You know, if you look deeper into there, or if you use your AI or whatever, maybe you can pick out some other types of wetlands and other habitats as well. And we're interested in that mix and how we talk about the whole landscape and the component types, really, because there's not much to choose from in our habitat classifications. Blanket bog, active bog maybe, degraded bog, that's kind of it, really. But I think anybody who walks across these sites realises that, you know, there's lots of different things going on. There's deeper bits, there's eroded bits, whatever. So we've been trying to develop a sort of bottom-up approach, looking at the whole landscape. And part of that is thinking that androgynous development of peat sits on top of the pre-peat landscape from a long time ago, but that's still there. You've got your ombrotrophic peat there on the top, that top layer. In England and Wales, it's often eroded and quite dry. And underneath it, you've got the ground, you know, the pre-peat ground, and you've got minerotrophic habitats as well that sit there alongside. So there's a lot of stuff going on. All the countries of the UK have these ambitious targets to restore degraded bogs, because most of them are degraded, but in many different ways. So again, we've been talking about that, haven't we? About what different types of things you've got. So we need to do something about them, but there's many and various different types. So again, part of our project was saying, well, what are the component types here? And can we sort of develop some categories to get people talking about things in the same way? So we had some aims. We want to use what we call the wetland framework approach to develop a wetland habitat classification to give us a more holistic understanding of the types of mired vegetation that you find in these places. It should be a basis for assessing likely outcomes of conservation actions and restoration trajectories, maybe, what you might expect to happen. So again, with your ecotopes and things like that, where do you think that water table is actually going to end up and things like that? What might you expect to see on the ground in different places? And what we've been doing is using new and existing data sets as the basis for that. So we've been trying to get information out of people, but we've also gone out and collected a new data set over a couple of seasons. So what's our approach? This is something that's been developed by colleagues in Sheffield University. So Brian Wheeler, some of you might have heard of, and Sue Shaw were very involved in this, and colleagues from the Environment Agency supported that work. It was published in 2009, so it's quite a while ago now. And what we do is we look at the surface, so the vegetation, but we also look at other site features. Topographical context is really important. We're lucky because we have LiDAR coverage over the whole of England and Wales now, pretty much, so that's really helpful. And once you have it, you wouldn't be without it, really. It's such a game changer, really. We're interested in management, including restoration in these sites, erosion features, and the underlying geology. So all these things come into the mix when you're talking about wetlands. Vegetation is what we see on the surface. So it's really important, and we've got a classification, the National Vegetation Classification, in the UK. I think it's different in Ireland, but I quite like your scheme as well. And our approach is to try and select a visually uniform stand, to record the stuff in it, or to use existing information if it's good quality. We then look at surface conditions, so wetness and stability, so these ideas of, we wouldn't necessarily go out and actually measure the water table, but if you go out in the summer wetness is really quite interesting. Even in a dry summer this year, on some of our sites that we've been to, even in the Peak District near where I live in Sheffield, the water table was within that magic 15 centimetres, which we were quite surprised by, actually. We collect information about pH and electrical conductivity, just as a sort of marker, helps you to understand whether your site is getting any of the sort of minerotrophic influence. Again, it's difficult on a substrate like granite or whatever, but again, if you've got those little bits of calcium coming in, if the water's been coming over the ground, it's picked up some minerals usually. And we'll be looking at microtopography because we know from all the work that's been done over the years that is really important. It's not just about your lists of species, it's about the sort of structure of the habitat. And also the subsurface environment. So again, these lovely rods that are just easy to carry and screw together, they just help you to understand that dimension of the peat. If you've got time and energy, a little bit of augering can tell you something as well. And if you know something about the mineral material underneath, that can be important. So that's our approach. It's what we use in the lowlands as well, and it's what the original wetland framework is based on. And what we've tried to do with this project is extend that thinking and that approach into these upland landscapes as well, which are just more, they're bigger, aren't they? They're bigger, a bit overwhelming for someone who's used to going into something much smaller. So what we've done is we've looked at some exemplar sites from England and Wales. We started in 2022 with a pilot study of 29 sites, and it was in the winter as well. So those are the green sites on the map. And so we did collect a whole data set. We analysed it, did a multivariate analysis on it, had a little think, and came up with sort of new androgynous wet mech categories. And so the wet mechs are the water supply mechanisms. So the recognition that there's different things going on if you're on a flat bit to a slopey bit or whatever, or a flow line or something like that. We realised that it's not fair, really, to base a whole new system just mainly on the South Pennines and bits of Northumberland and a few selected locations in Wales. So this year we've been able to go out in the summer and have a wider scope with our sampling. So we've looked at Cumbria, Wales, southwest of England, North Pennines, North Yorkshire and Northumberland. So I see this as, it's a bit of a tour of England and Wales. We've done some sort of transects, across the sort of blanket Maya landscapes. It's been really interesting to just see what's out there, what the different types of bog there are. And we have focused a lot on, we've tried to find good quality examples and not just look at eroded and restoration areas. They're important, but if you're thinking about what you're aiming for, you need to know what that really good quality stuff looks like. So our aims were to test our methods and ideas, to check how robust our categories were in terms of our thinking about new wet mechs and what's going on, and link that to the existing scheme that we have in the lowlands. So in the lowland scheme, we had 20 water supply mechanisms that came out of a huge data set of thousands of samples that were collected over the career of Brian Wheeler, which sort of started in the 1970s. So it's a long-term data set. These are the original ones. You can see there were two there, domed androgynous surfaces, so raised bogs, buoyant androgynous surfaces, these sort of quaking bogs, that were within that category, that sort of system. These are under review now, partly with respect to and in addition to these new androgynous types, partly because this is quite a complex system, and we think we'd like it to be more accessible, really, for people. So we're looking at this again and trying to develop something which can be more easily applied by people who are going out and observing their sites. But anyway, to simplify it, the main categories of wetland in relation to their reasons for wetness are either they're topogynous or they're sloping. So effectively, in these ombrogynous examples, we came up with topogynous bog, so where you have these accumulations of peat in basins or troughs, often mounded, so like mini raised bogs or whatever. So as we've said, it's that continuum really in the blanket mire landscape. But then these hill bog areas where the ombrogynous peat surfaces are on the hillsides and they kind of follow the shape of the underlying mineral ground a bit more closely. You know, topogynous bog can be embedded, and often is, in hill bog. But what we found is drawing sections was very useful. It's a very exaggerated vertical scale here. But we found that the configuration of the peat deposits was really interesting. And so when we drew up our diagrams like this, we found that the drainage patterns are really important. So, you know, effectively, you get the deepest peat furthest away from the drainage. And often this sort of arrangement. Now, the top picture here is from a section of Cors Carron, Tregaron Bog in mid Wales, so a classic raised bog, if you like, lowland raised bog. And this one below is from Walton Moss in Cumbria, which has been sort of regarded as a blanket peat deposit. But you can see it's a very similar configuration of the peat. So we found these in a range of locations, both in the uplands and in the lowlands. Recently, we've been in Dartmoor, and we've been to a bog called Tor Royal Bog, which is a famous bog down there. The raised bog in the southwest, it's really a fantastic site, and it's been receiving some restoration work at the moment or recently, it's finished now, I think, by the Southwest Peat Partnership. But again, we found a strikingly similar kind of arrangement there, so we were very pleased with that. Yeah. And this is what we've been doing. We've been sort of going around and then drawing up these sections. We do our transects and then we draw them up. So we find this really nice way of working, because if you've got your LiDAR, you can think, well, where am I going to go and, you know, sample across a site to take in these different subcomponent habitats, and then you can do crossing diagrams. So this is a cross section of Ringing Low Bog, which is near where I live up in Sheffield, and you can see that you've got this sort of hill bog on the side, so following the shape of the underlying ground, and then you've got this topogynous situation in the middle here. And in the other section, the long section, it looks like this. So it's sort of sloping down, and we sort of map the wetness and the plant communities that we find on the surface as well. And it just helps us to think about what's going on. So what we find is that we found this two different ways of thinking. So this idea that you've got conformation of the lower peat layer, which relates to the topography of the actual landscape that it's sitting in. And then you've got surface conditions as well, which we've called our wet mechs. So these are our water supply mechanisms. And we came up with 5 different types. So it's not too much to add. This is England and Wales. I think probably in Scotland and Ireland there may be more, but this is where we've got to so far, and which we've been testing. So I'm going to quickly show you some pictures of these. The names are under review. These are just things that we came up with, but again, it's interesting just listening to how people refer to sites to think about, well, what names might be helpful or not, really. So the first one is ombrogynous crowns. So that's the top layer, the water-shedding surfaces, the flat bits, if you like, the central bits maybe, often slightly mounded, usually with particular type of vegetation, often with a nice microtopographical sort of pattern and a spongy wet surface. And then next to that, usually deep ombrogynous slopes. We don't really like that name. If anybody's got suggestions, that would be helpful. But it did come out as a clear category, so often peripheral to these sort of flat bits in the middle. We've got the hill slopes, so the classic sort of hill bog, fairly thin, but still up to sort of 3 or so metres deep, maybe a bit more. It's difficult to find a threshold with peat depth, so that's often more degraded and uniform looking, and often associated with erosion features as well. And in the South Pennines, this is a huge issue, but I think everywhere maybe. Wet Mech 4 was androgynous percolation surfaces, which again, it's a bit of a mouthful, but this idea that where you've got a trough or a valley head, so you've not got mounding here, it's sort of flat across and you've got water sort of moving through, often with sort of pools or an axial soakway. Maybe with a bit of minerotrophic influence as well. You know, that's something that is definitely happens, and once you start looking at that, you see more of that, I think. And then flow tracks, but again, I've heard flushes referred to, and I think that's what we're meaning here. So lines of flow where the water actually preferentially flows sort of through those surfaces and off the site. And then we've got the minerotrophic features, which can be assigned to the original wet mech. So that's been quite useful, but some of them, so it's often lag zones and things like that around the edges, you know, being formed by water outflow or whatever, either from the surface or from springs or seepages. And we can see those in many other sites that we know well. So this is a site confusingly called Fen Bog in North Yorkshire, which really is a right old mixture, but it's a very nice sort of case study. Yeah, and these blanket mire landscapes, they're often flanked by moorland, you know, these right mixtures of things. And you've got, if you've got a situation which is quite acidic, like granite in Dartmoor, you know, you do have the similar sort of vegetation in the areas which are actually minerotrophic, which are picking up nutrients, even from granite or whatever, that little bit of extra. So, you know, understanding a bit about where you are and sort of thinking about what's actually going on. Sometimes it doesn't really help you. You need to go and look at the vegetation and know enough, I think, about communities and things like that. So we have been trying to tie what we do to well-recognised plant communities, because that's, you know, plants that people can see and understand. So these are some of the pictures, little sketches that we drew to sort of show the how the configuration underneath of the peat body, that's the orange bit, and the letter on top would be the wet mech as well. So to see how these things sort of go together. So those things aren't really associated with hill bog, but these are some of the sort of mounds that we found. So you can see the C letter, the letter C on there is the crown, these crown areas, and then the steep slopes. And then these troughs, and you know, these are quite complicated, but again, quite interesting to actually look at the configuration. So what we found was that areas that we regarded as good examples of active bog habitat, so this is this code M18 in the UK, often correspond with areas of topogynous bog, so these mounded areas or troughs. And if you look in the Nature Conservation Review, some of the sites that are written about there, they are often these topogynous bog sites. We wanted to know whether hill bog sites actually were of the same sort of quality, if you like. Were they less, you know, are these areas remaining refuges of something that was once more widespread? And we're not talking about thousands of years ago when there was sphagnum imbricatum or austinii everywhere, but in more recent memory. This was a difficult thing, hill bog and topogynous bog. It's very eroded often. And what we did is we tried to look at less damaged examples in our work in 2025. So what have we been doing? We've been looking in various places. We've been trying to actually map ecohydrological units, both peat configuration and wet mechs. We've been doing a lot of collaboration with colleagues, particularly in Wales, to describe new subunits of the National Vegetation Classification, which represent frequently encountered habitats. And we've identified those through actual field sampling and multivariate analysis, but we're going to try and do some descriptors of them to talk about the wetness and so on as well. new units based on important habitat features as well as species composition. So just a few interim results. There's my LiDAR map of a site in Dartmoor called Winnie's Down. We did various transects across it, so I'm going to show you one from east to west and then one from north to south. That's what it looks like. It's very millenary here in the southwest, but hopefully you can see in the distance, my colleague Phil traipsing across, it's sort of reddish in the distance. And this is just a really quick sketch, but so you can see the sort of the peat cutting, the very disturbed area on the eastern side on this sort of hill. But then you can see the sort of topogynous bog in the hollow with a sort of crown area, which was vegetation with pools in the middle. And then looking north to south, again, you can see that crown area and then the deep slope. And this is what the Dartmoor crowns look like. They're really rather lovely. And, you know, like some of the nice pictures of really good quality bog, which we don't have that much of, but it's there. We also went to Moorhouse, which is a famous site, and we looked at some of the areas which have been well documented. So a place called Valley Bog, it's not very imaginative name, a place called Knockfell and Troutbeck. And so Valley Bog looks like this. And essentially that bit there is a sort of wet bit in the hollow, very deep peat, sort of 7 metres of peat, I think. But you can see there's inflows coming into it. We've got a bit of minerotrophic influence here, pretty weakly minerotrophic because it's very wet up there. Some hill bog on the side, so thin following the shape of the land. And we think this is an ombrogynous percolation surface, so this trough bog. It's not mounded, it's on deep peat and the water's sort of percolating through and then it feeds out. And this is the sort of view, so you can see the component types here. Different things going on. But you've got some quite nice, good quality bog here, even in these heathery bits, with nice big mounds of sphagnum, which is not something we have in the South Pennines, really. So we can try and map that. So you can see this is the green blob is what I've mapped as the sort of this wet mech 4, or ombrogynous wet mech 4. And this is what it looks like, sort of underneath, so you can see again the topogynous sort of nature of that trough and the slope. It's not mounded, and then the hill bog in between, and then coming across the other way. So Knockfell, eroded, it's a bit like this. Lots of peat pipes, gullies. It's very high altitude for England as well. It's 700 metres. Again, it's my LiDAR and hill shading thing. We go from the bottom basically to this side. On this line, you can see the peat depth is still a couple of metres, but it's following that sort of line of the underlying mineral ground. So a more straightforward sort of situation, but with quite a lot of recolonisation of eroded areas there. And then we went to one in the middle, which was much more interesting, really, because it was a mixture of hill bog and then a very eroded area. So this is one of the pools that we found. Sort of on the edge, you can see a very eroded area there. And this has got things like sphagnum, I think it's called sphagnum medium now, sphagnum magellanicum to people my age. But quite nice pools, you know, quite an interesting habitat, but very eroded. And what we think it is an eroded topogynous bog, which has developed over a hollow originally, but embedded in a hill bog. And I think even in 1969, there was a famous paper written about the vegetation at Moorhouse, and they said exactly that some of these particular vegetation types, areas of wet vegetation, were particularly susceptible to erosion for some reason. I don't know why. So again, looking at our transect, we're going from the top of the hill down, and you can see the sort of hill bog, which is a bit, you know, it's a little bit variable, but then you can see this hollow in the middle, this eroded topogynous bog, and then the hill bog carrying on sort of down the hill. So it might, I mean, I don't know whether that makes any sense. It's all a bit preliminary. We're still doing the field work. I've got another stint in Wales next week, and then we'll be reanalysing everything. But we think it's got good applications for habitat mapping, habitat condition monitoring. You know, again, when you're on these big sites being faced with, you know, a large site, actually thinking, I'm going to do a transect and I'm going to systematically sort of look at stuff. You can do this in a day over quite a large area, and maybe it could be quite consistent. So it could be a consistent way of sort of mapping particular features and developing a bit of a baseline that you can then do more monitoring on to maybe pick out particular ecotypes or whatever in terms of like where the water level should be and so on. Maybe even developing realistic restoration trajectories, because if you're on these hill bogs, maybe you're not going to be looking for great pool systems or whatever. You might be happier just with some, in the Peak District, we love just some mounds of Sphagnum capillifolium. That'd be great. And maybe thinking about resilience in the future as well. So again, your intervention should help with resilience. And I think in England and Wales, unfortunately, it might not be to do with actually sequestering carbon, but it might be to do with just keeping it in there, really. So that's a picture from Scotland, and we haven't been and done any fieldwork in Scotland or Northern Ireland, but we're going to be finishing our fieldwork in England and Wales early in October, doing our data analysis and reporting, trying to develop materials so that people can actually go and test the approach if they'd like to. And we'd love it if more people got involved, identifying suitable sites for further study, testing materials, providing feedback, or sharing existing or new data sets. We know there's a lot of information out there in terms of people going out and testing peat depth and recording the surface. And so if you match that up with all your LiDAR and everything, maybe we could think about which areas. We could maybe even see if topogynous bog areas respond better to some of the interventions that people make, and so on. We would love it to extend this to Northern Ireland and Scotland, not necessarily do the fieldwork ourselves, but again, collaborate with people. It would be really nice. And I'd like to say a big thank you to all the people that have collaborated with us in England and Wales so far, because it's been very interesting to see all these lovely sites. So thank you very much.